All right, these are the answers to the last two pages, which all have to do with related rates. So 14 says the radius of a circle is decreasing at a rate of 3 centimeters per minute. So that's dr dt. It's decreasing, so it's a negative 3 centimeters per minute. Okay. Find the rate of change of the area of the circle when r is 5. So we need an area formula. We want dA dt. That's what we're looking for. So I'm going to take the area formula. Area of a circle is pi r squared. Usually they'll give you those formulas. There are some cases where I've seen them expect you to know the area of a circle or some simpler things, but anything complicated they're going to tell you. All right, so now we take the derivative of this. The derivative of area with respect to time is, I do the area derivative of r squared, that's 2 pi r, and then derivative of the inside, dr dt. So there's our derivative. Now we're going to put negative 3 in for dr dt. We're going to put 5 in for r. So our change in area with respect to time is 2 times pi times 5 times negative 3, which will give us a negative 30 pi square centimeters, because we're talking about area, per minute. And those units are really important. You often get a point just for having good units. And so we want to make sure we're clear on that. Number 15 says we got a Boolean soup cube with side length 1 inch is placed in boiling water. We're talking about a cube. Assuming roughly resembles a cube as it dissolves, at what rate is the volume changing when the side length is a ½ inch and if the length is decreasing at a rate of this? So the length is decreasing. That's a change in the side, if you will, or the edge. We'll go edge here, dE dt. Is 1/32, and the edge at that time was 1/2 inch. All right, so what's our volume? Volume of a cube is its edge length cubed. You can use S if you'd rather. It doesn't matter. The E is not special. But when we take the derivative, dV dt is equal to 3e squared times dE dt. So we're going to put 1/32 in for here, and 1/2 in for there. And so our change in volume will be 3 times 1/2 squared times 1/32. Okay? And if we do that, we're going to get 3 over 128. And that doesn't reduce, so that's our change in volume. And it's decreasing, so really technically I should probably have this as a negative on these. All right? And what are the units? Because this is volume, it's going to be cubic inches per second. And I'm just borrowing whatever the units were from above. We're kind of using them down here. All right, 16 gives us the volume of a sphere. It says air is being pumped into it at a rate of 200 cubic inches per minute. So this is change in volume over change in time. dV dt is 200 cubic inches per minute. Find the rate of change of the radius. So we're trying to find dr dt when the radius is 10. Okay, so let's take the derivative. Change in volume over change in time is 4/3 times pi times r cubed. The cube's going to come down. 4/3 times 3 is 4 pi, and then I'm going to have r squared times the derivative of r, which is dr dt. All right. Now, at this point, I'm putting 200 in for dV dt. So 200 goes here, equals 4 times pi times the radius, which is 10, so 10 squared, times dr dt, which is what we're trying to find. Okay, so this is going to give me 400 pi. If I divide, I'm going to get 200 divided by 400 pi, which is really 1 over 2 pi, if I want to leave it like that, dr dt. Or perhaps you'd rather do it as a decimal, which I don't know if I'd blame you. And if you do it as a decimal, you're going to get 0.159. And it's a radius, so it's a linear measure, so it's going to be inch per minute. So not very fast, but that's what we end up with. Again, this would be the exact 1 over 2 pi. This is the decimal approximation. Okay. All right, number 17, we have a ladder up